Welcome students. Here we will see a question from the chapter Mathematical Induction. Here question is, prove the rule of exponents a into b whole to the power n is equal to a to the power n into b to the power n by using principle of mathematical induction for every natural number. Okay. So let us see the solution here. We have to prove it by principle of mathematical induction. So let us see the solution. Here given mathematical statement is a b whole to the power n is a to the power n b to the power n, and as we know mathematical statement is denoted by the notation Pn. So here Pn is a into b whole to the power n is a to the power n into b to the power n for all natural number n. Okay, all n belong to the set of natural number. So you know, by the rule of principle of mathematical induction, this problem can be proved by using this principle. So first step, we have to show that P1 is true, and we will get P1 by putting n is equal to 1 here. So let us call it relation number 1. First of all, we have to show that P1 is true. We have to show that P1 is true, and for this we have to putting n is equal to 1 in relation number 1. So we will get here P1, putting n is equal to 1, we will get P1. Here left hand side will be AB whole to the power 1, and right hand side is A to the power 1, B to the power 1. Or this is simply A into B because power is 1 here. So A into B. Similarly in right hand side also this is A into B. A to the power 1 is A, B to the power 1 is B, you know. So this is AB. That is LHS is equal to RHS. Therefore P1 is true. So this is the first step. Now second step, we have to assume that PR is true. So now assuming that PR is true. How will we get PR? We will get PR by putting n is equal to R in relation number 1. So putting n is equal to R in relation number 1. So we will get PR will be AB whole to the power R is A to the power R, B to the power R. We are assuming that this statement, this relation is true. Okay. So let us call it relation number 2. Now third and last step, final step, where we have to show that PR plus 1 is true. And for this we will put n is equal to R plus 1 in relation number 1. So now putting n is equal to R plus 1 in relation number 1. We will get here P R plus 1, putting n is equal to R plus 1 here. And statement is AB whole to the power R plus 1 is equal to A to the power R plus 1 into B to the power R plus 1. We have to prove here that LHS is equal to RHS. We have to show it. This is third step, last step. Okay. We will start with left hand side LHS and we will come to the right hand side. It will be proved. So here LHS is AB whole to the power R plus 1, and this can be written as AB into AB whole to the power R, because here exponent is 1. So ab to the power 1, ab to the power r, and this is equal to ab into, by relation number 2, ab whole to the power r means this much is equal to a to the power r into b to the power r. So into a to the power r, b to the power r, and this is equal to, here a to the power r into a is a to the power r plus 1. This is a to the power r plus 1. Similarly, b to the power r into b is b to the power r plus 1. So b to the power r plus 1. So you see, we have started with LHS and we are coming to the RHS. RHS is this much, so we are coming to the RHS. This is right hand side. So we are getting here, therefore LHS is equal to RHS. That's all about this solution. And at the last, we have to write one line statement here, that therefore by the principle of mathematical induction, by the principle of mathematical induction, Pn is true for all n. Pn means this statement is true, which we had to prove. Pn is true for all n. Okay, so this is the proof of this question. Fine. So that's all about the solution of this question, and I hope that you have understood it very well. And in many videos we have done so many questions from this chapter, principle of mathematical induction, and you might have a good command over this topic, and hope you are enjoying mathematics and you are watching these videos continuously. So wish you all the best. Thank you very much.